Hello superstars or welcome back to Beyond Skills 24/7. It's me, your host, and today हम सीखने वाले हैं how to basically put a supercomputer on fast forward. थोड़ा tricky है, so you better buckle up and try to keep up, okay? चलो, let's dive right in.
So, ये है आज का game plan, our pro level cheat sheet for today. We're gonna start with the villain, फिर मिलेंगे hero से, and then step by step we'll uncover all of its amazing superpowers. Ready to master this whole thing? Let's go.
Okay, first things first. Let's talk about the pain. The real pain of just waiting and waiting for complex simulations to finish. I mean, think about weather forecasting, fluid dynamics, या फिर designing the next supersonic jet. ये चीजें दिन ले लेती हैं, sometimes even weeks. They are just so painfully slow.
Seriously, कभी हुआ है आपके साथ? You hit run on a simulation, और फिर lunch, dinner, अगले दिन का breakfast, सब हो गया, but it's still chugging along. That's because these systems have millions, maybe even billions of variables. This insane high-dimensional complexity, ये है हमारा villain, the big boss we're here to defeat. But you know the rule, right? जहाँ villain है, वहाँ hero तो आएगा ही. And our hero is ROM. That's Reduced Order Models. And listen, this isn't just some quick fix. It's a totally elegant and powerful way to turn days of waiting into just a few minutes.
So here's the secret sauce. Most complex systems, no matter how chaotic they seem, have these hidden patterns. एक underlying simplicity होती है. ROMs are brilliant because they find that simplicity and totally exploit it. So instead of tracking millions of points, we learn to track just a few key patterns that basically define the whole system. Smart, right?
तो सवाल ये है, how do we actually find these important patterns? इन VIPs को ढूंढे कैसे? Well, the first big secret is coming up right now. So ध्यान screen पे रखो, this is where the real magic begins.
So how do we find those patterns? We use this cool thing called proper orthogonal decomposition, or just POD. Think of it this way. You're making a really complex biryani with like 50 ingredients. POD is the master chef that tells you, hey, you only need these 3 or 4 key masalas to get that signature flavor. It finds the most important ingredients of your system and lets you ignore all the noise.
And it's actually a pretty simple 3-step process. First, you just watch your system and take pictures or snapshots over time. Then you feed all these snapshots into this powerful mathematical engine called SVD. And boom, just like that, SVD spits out your VIPs, the most important modes that capture almost all of the system's energy.
I'm saying this again because it's so important.
Look at the screen. The key word here is optimal. ये कोई random modes नहीं है, okay? Mathematically speaking, these are the absolute best modes you could possibly find to describe your system. They pack the most punch, capturing the maximum energy with the fewest modes possible. It's efficiency at its best.
Okay, so we've got our VIPs, our secret masalas. Ab kya? Well, now we use them to rewrite the entire rulebook of the system.
Let's go back to our biryani. Once we have those secret masalas, we don't need that super complicated 10-page recipe anymore, do we? We can rewrite it using only those key ingredients. And suddenly, that complex recipe becomes a simple one-page cheat sheet. That is Galerkin Projection. We take the big, scary laws of physics and just simplify them.
And this slide just says it all, doesn't it? On one side, you have the full model. Slow, expensive, super heavy. It's like taking the stairs in a skyscraper. And on the other side, our reduced order model. Sleek, low-dimensional, and blazing fast. That's the super fast elevator straight to the top. You get to the same place with a tiny fraction of the effort.
But life is never that simple, is it? We've taken the super-fast elevator, but what happens if it sometimes gets stuck on a floor because the door mechanism is, well, it's complicated? There's still one tricky little problem we need to solve.
So here's the thing. Even with our nice, simple model, some calculations can still be a headache. I'm talking about these nonlinear terms. They're like the party crashers. They can show up and make our super fast model slow right down. So how do we handle them without losing our speed advantage? We handle them with DEIM. This is the ultimate smart hack. Instead of calculating that complicated nonlinear term everywhere, DEIM basically says, look, just tell me the value at a few very specific, very smart locations, and I'll figure out the rest for you. It's an incredibly clever shortcut that avoids all that brute force work.
Now, DEIM is what we call a greedy algorithm. But trust me, it's greedy in the best way possible. It doesn't just sample randomly. After it takes a sample, it asks a very smart question. Where is my approximation the worst right now? And then it puts its next sample point right there, exactly at the spot with the biggest error. It smartly hunts down the errors one by one.
And this is just, wow. Just look at this. Check out the top two plots. On the left is the slow, full simulation. On the right is our super fast ROM. I mean, come on, they're almost identical. And what's the secret? Look at the graph below. You see those three little vertical lines? Those are the only 3 sample points DEIM needed to choose. Just 3 smart points were enough to reconstruct that whole complex behavior. Isn't that mind-blowing?
So there you have it, a complete toolkit to make your simulations unbelievably fast. You've learned how to find the very essence of a system, how to rewrite its rules, and how to handle all the tricky parts with a very, very smart hack.
All right, let's do a super quick final recap. ROMs make simulations fast. POD finds the most important patterns. Galerkin Projection uses those patterns to create a simpler model. And DEIM smartly samples to handle the complicated nonlinear bits. And just like that, you are now officially brilliant.
तो अब ये superpower आपके हाथ में है. So here's your homework from me. What big, real-world problem would you solve with this? Better climate models? Real-time digital twins? Maybe designing life-saving drugs? The possibilities are literally endless. So think about it. This is your host, signing off from Beyond Skills 24/7. Keep learning and stay brilliant.